Well, here we are with test number 7. I hope you guys are getting something out of this, and I really enjoy putting these together. Now let's see if I can forge my way through this, see if I've made any boo-boos building my slides. I tried to make them all just as accurate as I possibly could. Question number 1. A speed density 4-liter 2001 Jeep Cherokee in Panama City, Florida has a baro reading of 26.4 inches of mercury. What will happen? Will it be lean with high fuel trims, rich with low fuel trims, no start on a cold morning, or black smoke at engine idle? Question number 2. An engine misfires, but only at idle. What is the most likely cause? We got weak coil output, low injector flow, small vacuum leak, or worn plug gap. Question 3. Exhaust gas analysis shows high NOx readings. What's the most likely cause? Skewed ECT, mass airflow offset, weak spark, low EGR flow. Manual transmission vehicle won't idle down after stopping. Most likely cause, TPS deflection, AIR, in other words air injection reactor pumping, EGR sledging, or throttle sludge. Question 5. After a short hot soak, the engine produces a lot of blue smoke when first started. What do we have going on here? A head gasket leak, stick-in oil rings, valve stem seals, or a clogged PCV valve? Question 6. On a 3-liter, this is a tricky one, 142536 engine, well, that's the firing order, with a skip and no compression on number 1. Pumping smoke into the number 1 spark plug hole at top dead center, compression produces smoke at the number 3 spark plug hole. What does this mean? Does that mean the number 1 piston is compromised, the number 3 exhaust valve is stuck open, the cam or the crank out of time, or you got a bad number 1 exhaust valve leak? Question 7. Alright, see this Taurus driving along down the road? Got a little bit of a road surge here. A vehicle with no stored DTCs surges at steady 45-mile-an-hour cruise on a flat road. What is the least likely cause? TP sensor, ATF fluid, coil pack, or EGR flow? Question 8. An AC starts out cooling just fine, but the air from the registers gets warm and the belt begins to squeal. Is this a viscous fan clutch issue, a broken blend door, rust in the radiator, or R134A contaminated? Question 9. With no stored DTCs, an engine sometimes has a sudden RPM surge at a traffic light severe enough to cause the vehicle to lurch forward. Is this a dirty throttle body, canister vent valve, leaking injector tip, or saturated canister? Finally, question 10. The red brake light has been coming on every week and brake fluid has to be added, but there are no visible leaks. They've got all these choices here. They didn't dial themselves in right. We have a bad master cylinder, ABS HCU cross leak, caliper seals are hard, or clogged brake hose. Answers. Speed density 4-liter 2001 Jeep Cherokee in Panama City, Florida has a baro reading. That's going to be lean with high fuel trims. Because whenever it's reading high altitude, when it's at sea level, it doesn't have any rationality check on a lot of vehicles, particularly speed density ones, which is speed density one uses a map sensor primarily. Your newer vehicles will substitute map for MAF if they have both sensors. In other words, if the mass airflow is known to be inaccurate, it'll start using MAP and it'll switch to speed density operation, to calculate fuel and all that. But the long and the short of it is, if it thinks you're at high altitude, it doesn't know anything other than to reduce the amount of fuel. And it actually will advance the ignition timing too, because that's another altitude adjustment that has to be made. And what that typically will do will cause it to put less fuel in there. The oxygen sensor will pick that up as not enough fuel. The fuel trims will ratchet way up. Your short fuel trims may be at 0, but the long ones will be way up at 26, 28. And that's how you'll, you know, what you'll be noticing about that. But if you've got a reading like that, if you got a reading like this right here, and you know you're at sea level, which it ought to be reading like 29.8 or something like that at sea level, know what your readings are supposed to be at your altitude. This is going to depend. Some of you guys listening to this may be in Colorado, some of you may be in Kentucky, Tennessee, whatever. In our area, we're at about 400 feet above sea level, so our air pressure is going to be very close to the same as it is at sea level here. But you got to know what it normally is at your place. Now, if you're up in Colorado somewhere, this is probably going to be accurate. But remember, I said we were at Panama City, Florida. That's right there, down on the ocean. This misfire, it's the true story here. Misfire is only at idle. What's the most likely cause? I didn't put anything in this box right here, which was kind of dumb. But what we got right here was we had a misfire on cylinder number 1. We pumped smoke in there. We looked with a bright light. We saw it squirting out right here. When we pulled the intake manifold off, there was a crack in that gasket right there. And that was causing it to skip at idle. It's on a Toyota Cressida. Those things are old. But still, it happened, you know. Question 3. Exhaust gas analysis shows high NOx readings. That's going to be whenever your EGR is not working. Now, when the EGR is working, now this is going to non-variable valve timing vehicles. Variable valve timing vehicles, they just close the exhaust valves a little early and trap some of the exhaust gas in there. They don't have EGR, but because they don't need it. You know, it's kind of like with electronic throttle body, your cruise control built into the PCM. Well, this is kind of like that too. So, but if the EGR valve on one that has it is stuck shut, and you're driving down the road and you got your sniffer in there and you got your exhaust gas, and them things cost $5,000 or $6,000. So I don't expect everybody to have a exhaust gas analyzer. You know, that was the picture I took was one that I had at the college. It was about a $5,000 tool, but it was about the size of a scan tool. It worked real smooth. But anyway, about 5% of the EGR is exhaust gas is recirculated when you're cruising, not when you're idling. Now diesels, some of the diesels will open the EGR whenever they're idling, and that makes them idle really quiet. So they go by slightly different rules. EGR is there for the same reason, but it reacts a different way to it, which I thought was, you know, kind of interesting when I first learned about that. But anyway, so that's going to be low EGR flow. Now this one here is one that I saw. This is photos of one that I took a picture of, and I had fixed other vehicles with different problems like this too. TPS deflection. Notice this thing was reading part throttle. It was still in this dash pot mode. You can read these words down here. You know, the old dash pot on your carburetor, whenever you let off the gas, it would catch, it was a little diaphragm looking thing, and it would catch the throttle lever and then slowly let it come down to idle, and that kept it from being so prone to stalling sometimes. And so the interesting thing about it is these idle air control valves do the same thing, and your electronic throttle bodies do the same thing. But if they're still seeing part throttle when you've already let off the gas because of an issue with the electrical circuit on the TP sensor, it's going to say idle too high, you know, and that bothers people. On a manual transmission is one of the ones you'll most likely to notice it, because you're going to have your foot on the clutch sitting there. And so we could actually jiggle these wires right here like you see my hand doing, and it would drop to closed throttle and the RPM would lower. Well, put a sensor on there, didn't do anything for it. So what we did was, and I had done this on other ones, you pulleys, unkey these 3 terminals, keep them in order, and have them standing up. Don't have them hanging down when you do this, or solder will run down into the terminal, and then you're going to have a connector. But if you got them standing up, these crimps looked really clean. But when we soldered those crimps, and just got it good and hot, let that solder flow in there, capillary attraction, and plug that back in, it never gave that problem again. I had actually seen vehicles that would be throwing a mass airflow sensor code, and I did the same thing with them. I would unkey the wires, pull them out, solder the wire crimps right there at the connector, plug them back in, never have another mass airflow code at all. This typically happens after you've replaced the sensor and you're still getting the same code. There's a lot of other reasons that can happen, but this is something that's not a lot of trouble, and it doesn't cost anything much to do it. And if you do it and it doesn't work, then you just need to look somewhere else anyway. But I have fixed vehicles like this. Something else I used to do on some of the older Ford engine controllers that had these split barrel type connectors in there in the engine controller connector. Those split connectors would get, they've got a slit over a round pin, and the female pin was split, and it would get loose in there. And sometimes I would fix cars that were giving trouble that nobody else could figure out by just unplugging the engine controller, popping that red wedge out of there, and tweaking every single one of those pins so that they were tighter. And then I'd plug it back together, and whatever problem the car was given that had caused so many parts to be replaced would be gone. So there's a lot of stories I could tell about that. Question 5, after a short hot soak, the engine produces a lot of blue smoke. That's valve stem seals just about every single time. And these valve stem, particularly on these like this, they're really bad because that oil gets past those cam followers, puddles up down in there. I mean, those cam buckets, puddles up down in there, and then it goes past that hard seal, and it creates deposits like this. Usually if you do it long enough, let it happen long enough. This can actually also cause a surge that feels like an EGR surge, and when you unplug the EGR valve, it will stop surging because it's got this cruddy ice cream puffy stuff looking on the plugs. Now this one right here was one I actually showed my students. We had a vehicle and I knew what was wrong with it, and I said, well, let's just see what happens here. So we put the number 1 piston on top dead center, both valves closed, took all the plugs out, pumped smoke into the doggone thing, and smoke that we were pumping into the number 1 started coming out number 3. Well, number 3 is coming up on its exhaust stroke, and the exhaust valve is wide open with this firing order. It's not going to be the same on every firing order. You kind of got to understand the dynamics of how all this works. But when we saw this smoke coming out on number 3, I asked the students, what does this mean? They go, I don't know. And I said, well, if there's no smoke that should be coming out 3 because you're pumping it into 1 with all the valves are supposed to be closed, top dead center, compression stroke. So if you got to make sure you're on top dead center compression stroke. And your companion cylinder, if you'll put your companion cylinder on top dead center exhaust stroke, you'll know that its companion is on top dead center compression. That's pretty much how that works. But because of the fact that it was making its way through the exhaust and coming out the number 3 spark plug hole, that meant that there was a breach here. It had a burned exhaust valve, and that turned out to be exactly what was wrong with it. That was an interesting kind of test that you don't usually need to do. You can actually do a cylinder leakage test and, isolate the same thing, but we just did this for fun. Vehicle with no stored DTCs, surges steady. This is not going to be a coil pack. Remember, this is the least likely cause. Coil pack's the least likely cause because a coil pack, particularly if it's got a misfire bite, is not going to happen on a straight and level road. It's typically going to be on an incline when you're pulling about 45 miles an hour. That's really tough on the ignition to have to deal with that 45 mile an hour, torque converter locked, high gear, 45 mile an hour, crowding the throttle a little bit. That's where everything's under the most strain, believe it or not. But anyway, the TP sensor can cause this. The automatic transmission fluid can cause it if it's got the if it's a modulated clutch, torque converter clutch, and that's been the way. It's been that way for 40 years nearly now. Well, I say that since probably the late 80s. Torque converter clutches have not been a straight lockup. They basically will dither in and 10, 20, 30, 40, 50, 60, 70% and all that. And they're supposed to have friction modifier in there, and that's supposed to make that torque converter slip more smoothly. Well, if it's chattering because there's not any friction modifier in the fluid, then you'll feel a surge. And I've run into that myself on various different vehicles. EGR flow can cause a surge too. Even if there's nothing else wrong, if it's for some reason, if it's got too much EGR flow for whatever reason, it can make it surge. AC starts out cooling just fine, but the air from the registers gets warm and the belt begins to squeal. That is a viscous fan clutch, is what that is. See that? All right, watch this. If that video will play. Video probably won't play. Okay. That's not going to work. What we had basically done, there was one that came in was doing that, and I had a video that I had put in here that was supposed to play, but for some reason it didn't, probably because I bumped the space bar when I shouldn't have. Anyway, long and short of it was that Nissan was doing this. We washed the radiator and everything out. Didn't help, and we wound up putting a viscous fan clutch on it, and that's all it took to get that AC straightened out. Didn't have any other problem except airflow. And this spiral spring right here is bimetal, and as the air coming through the condenser in the radiator gets really, really hot, it makes this fan clutch more, I mean, it gets stiffer so that the speed of the fan more closely matches the speed of the pulley that's driving it. And they basically put the fan clutches on there because it helps save fuel, and it doesn't make as much noise, and the fan only does what it needs to do to help the airflow. Now, driving down the road, this thing wouldn't do it, but sitting still it would. But she did not have any kind of electric fan or anything. But that one had a
it sort of snowballs
like
up.
that. Now that
It's not really a giant jump, but the more you let it run, the more it'll go up, and it'll wind up here above 250. And so, but if we take our fan over there and we put it blowing through there, we're going to watch it cool down. Still got these same numbers. He's turning the fan on high, putting it really close, put it a little closer. He's putting that really close. See, this fan in here is working okay. You may check that fan clutch. But watch what the pressures are doing just because he put the fan over it. They continually keep dropping, and we never do hear that belt squealing. And we keep watching it.
One down. Just because the fan was on there, you could watch those gauges dropping, and that was that. When we put that fan clutch on, or we washed everything out, the radiator and all, made sure there wasn't any trash between the condenser and the radiator, and it was all even after we did all that, it still gave the problem until we replaced the fan clutch. So, do the smart stuff first. Now this one right here, I've seen this a bunch of times. What we got here is, and I didn't put any words in here either, but if they pack this thing full of gas, overfill it, it can saturate the canister. And if the canister is saturated, what will happen is sometimes when the canister just begins to purge, it'll just begin to purge, and it'll draw air into the manifold. And if the air that's going into the manifold has got a bunch of gas in here that wasn't expected, it can actually almost kill the engine, and then your idle speed control, whether it's electronic throttle body or idle air control, will move to save the engine so that it won't stall, and it can surprise somebody, because back in the day, the older vehicles didn't purge except whenever you were off idle. But these newer ones, if you're sitting there with your foot on the brake and you don't even have your foot on the gas, with it in drive at a stop sign or at a stoplight behind another car, it can actually, when it just all of a sudden decides to start purging the canister, it can just about kill the engine if you've packed the gas in to the point to where you've got too much gas saturated in this canister. Of course, this is your canister vent, and it'll just pull it right on out of there and slug the manifold with gas and make it go, and that's just scary as all get out when you surge forward and almost hit a car. And I have had people come to me, and I'd say, let's look into this. And we look into, with the engine idling, I'd watch the scan tool, and I would just wait until the canister began to purge. There's a reason why the algorithms are written where the various different cells for control. Some of them are purge-free cells, because they know that if you're purging, there's going to be fuel vapor going in there that it has to compensate for. Anyway, I'm watching this thing, and all of a sudden it starts purging, and I hear the engine almost quit. And I said, are you packing the gas in this thing when you gas it up? And they said, well, yeah, that's fine. I can have as much as I can get in there. We'll stop doing that, and this problem will go away. And without fail, every time they stop packing the gas, they stop having the problem. Once it clears all that mess out. This right here, I've actually seen too. The that line is not drawn there right. But anyway, these seals can leak, and you can get that fluid can go right into the booster. And you say, well, we keep having to add fluid. We're not seeing it leaking anywhere. The brakes actually seem like they work pretty good. Well, it turns out you pull this off, and we pulled the booster off of a Dodge truck we were working on, and we poured about a quart of fluid out of the booster. Just turned it up and poured it out in a can. I had a picture of that somewhere. But a bad master cylinder can let that fluid go right in here. Now you're going to see a little seepage on the front of the master cylinder, even if there's nothing wrong with the seals. If you see that the paint has been gobbled off of the front of the booster, rather because of a little bit of seepage from the seals, that is not a problem. It doesn't mean you need a master cylinder. That typically just means you're going to see that because there's a little bit of seepage is going to be there, but not enough to go in there and cause the fluid to get low and dump a bunch of brake fluid in the booster. Well, that finishes us up for today. We've been here 20 minutes. I hope you all got something out of this, and give me a message. Let me know. Share the video, and let me know if it helped you with your ASE.